Sig Figs. We said non-zero numbers matter. We said trailing zeros after a decimal point. We said zeros in between non-zeros. Those are all the significant things, right? I think we got it summarized. Bang, bang, bang. Okay. Now, so hang on to that worksheet because there's more on the back that you're going to do eventually, but we're not there yet.
Not? Didn't you say to do all of that?
What? No.
Oh. Oops.
Okay. I said just do the front. All of the front.
Math class.
I may have said all of the front. Yeah.
Okay.
You might have got it twisted, Holmes.
Here it goes.
That's fine. Good job. A+. So we still have to talk about what happens when you add, subtract, multiply, or divide significant figures. So let's talk about add and subtract significant figures. So let me pull an example right here.
Let's subtract.
Subtract that, yo. So if we have 25.340 plus 5.465 and 0.322, you can add all these guys together and get your 7, 4, 8, 11. There you go. And then your answer, since these are all accurate to the thousandth place, then our answer can be accurate to the thousandth place. That's pretty straightforward, right?
One's not accurate.
Aha!
Aha.
So that leads me to the next example, where we have 58.0 plus 0.0038 plus 0.00001. If we add all these things together, we're going to have 1,830.58. But since this thing is only accurate to the tenths place here, our answer can only be accurate to the tenths place.
That's 58.0.
So 58.0 is the answer that we're allowed to say with significance.
So if it's 58, it's going to be 58, right? 58 plus 10 plus 0.00, and then equal 58?
Yes. And think about it. If I was like, my car weighs a ton, and you were like, well, this pen weighs 3.7 grams, so if I put this pen in your car, then your car will weigh 1 ton and 3.7 grams. I'd be like, no, because that 1 ton isn't accurate, right? That's very rough. And so to say 1 ton and 3.7 grams, I mean, that's bananas, right? Do you see how that would be false? Yeah. So, so the rule for this is for adding and subtracting, you can only go to the decimal place of the term with the least accuracy. Did that make sense? What I just said?
Yeah.
Round to the decimal place of the term with the least accuracy. for addition and subtraction.
Groovy. Multiplication and division.
You know, maybe I should do another example just to make sure we're good with that addition and subtraction.
Can I ask a question?
Yes.
What if the 58 was in the middle?
Oh, it doesn't matter.
It still would be 58.0.
Yeah. Just any of the terms that are the least, it's, you know, the least accurate one, that's your bottleneck effect.
Okay.
Right? So that's, you're only as strong as the weakest link in your crew.
Right.
The lowest common denominator.
Yeah. Right, so that's, if you're running as a team and there's one person who's like slow and you can't go ahead without that person, like that's how fast your crew is. Your crew is as fast as that guy.
Yeah.
Right?
Everybody hates that guy.
Why that one guy?
Come on, bro. Really, with the donuts every morning? Okay. So let's do an example here. So let's say we have 3.64 plus 0.238 and 415.5.
418.4.
Bless you.
Thank y'all.
419.4.
So that would be the straight up, just adding them, but where are we gonna cut that off, Ella?
So 415.5 is your shallowest decimal place, so you can only go to the 10th place, so it'll be 419.4, so you'll round up.
But would you round up even if you can't go to the, would you use that?
You round to the nearest 10th.
Oh, okay.
So this 7 will make it go up. If this was 0.328, then it would stay 0.3. So you just round like normal. But you round based on what is the least accurate number. Okay, so multiplying and dividing examples.
What page is that?
It's back in the appendix. 433. So if you have 2.21 multiplied by 0.3. First, let's multiply and see what result we get. Does anybody need a calculator?
Yes.
Anyone else calculator?
Yeah.
0.663.
There's 0.663. Is that it, or does the decimal keep going?
That's
I
it.
got
Stops.
2.21 times, oh no, yeah, sorry.
Okay, and so now, here's the deal. We have to round to the number of significant figures of the least amount of significant figures. So this term has how many sig figs?
1.
This has 1 sig fig. This has how many?
3.
3 sig figs. But just because this guy has only 1, our answer has to be rounded to 1.
So 0.7?
Yeah.
Oh.
Yeah.
Okay.
This one seems a little more intuitive of like, yeah, that makes sense. This one you're like, why are you doing that to me? But maybe with some practice you'll see. And it has to do with the level of accuracy. There's like margins of error with your solution. And if you stick to this rule, there's the least amount of error possible in your calculation.
Okay.
if that makes any sense.
It's kind of like rounding out too. It's just like.
Yeah. So it's similar to this, where there's a bottleneck of who has the least sig figs. But then you could say to yourself, well, what if we had this times 1.3? What would that be? Because this has 3 sig figs. This has 2 sig figs. 2.873.
2.87. So it would be 2.9. 2.9.
Oh, 'cause we only have 2
Oh,
sig
yeah.
figs, not 2 faces.
Yeah, it's the number. So with multiplication and division, it's the number of significant figures. And here, it's the actual decimal place. So they're a little bit different. So the result, so multiplication, division, the result should be rounded off to contain only as many sig figs as are contained in the least exact factor. So round to the number of significant figures in the least exact term. And that's the same for division as well. So if we have 68.35 divided by 5.2, right? And so if you write all that stuff, I'm going to smack you.
13.1.
Wait, it's gonna be
13.1. No.
No,
13.0.
So how many sig figs here?
So it's just, is
Four.
it just 13?
Oh,
So
2.
it's just 13.
Yeah, so that our answer can only be 13.
Oh.
If you do the sine of 35 degrees, what's the answer to that? Sine 35. If you're in degree mode.
5735776.
57357.
436.
Blah blah blah. So you'll use the same amount of sig figs that are in the argument here for your sine function. So since there's 2 sig figs, we can give our answer here. Our answer can be 0.57.
Oh, but if it had like 3 sig figs, you would go.
Yeah, if you said 35.0 degrees, then we would carry out another one.
Okay.
And if we just said the sine of 30 degrees, well, here's the thing. The sine of 30 degrees is a half. So I guess that works out. There's 1 sig fig. But
Yeah, so
Side of-
150.
Because that 0 doesn't have a decimal. Wait. But then if you go sine of 20,
yeah, sine of 20.
is 0.34202014.
Right, so this, we would say there's 1 significant figure. So this is actually just 0.3.
Well, sine 30.
Hmm?
30 is already 1 anyway. 0.5 like this.
Yeah, because there's 1 significant figure,
Okay.
1 significant figure. So trig functions round to the number of sig figs in your, it's called the argument inside of your trig function. So that you could call it the angle if you wanted to. Round to the number of sig figs in your angle. Round